Alright, this is Unit 6, Day 1. We have parallel lines and their angles. Some definitions that you'd probably want to get into your notes would be these right here. Those are found in Chapter 3, Section 1 and Section 2 is where you can refer to these definitions at. These are the things that you need to know moving forward. So if you want to take a moment and hit the pause button and actually get these into your notes, you can do that. Alright, here's example 1, naming all segments that are parallel to segment BC. And by the way, there is an assumption here that this is actually a cube, or at least a rectangular prism. When we look at segment BC, it being the edge of this box, there are 3 segments that are parallel to it. Those would include segments AD, also segment EH on the back of the box, and also segment FG. Those are the 3 segments parallel to segment BC, no more than that. Name a segment skew to segment EH. There's actually a lot of them that we can come up with. Now, there is anything that's not on the same plane as EH, not on a common plane. So a line that's not on a common plane as segment EH would be segment DC. It's on a different plane, it never intersects at EH, and it's not parallel to it because it's not coplanar. So segment DC would be a possible answer here. You could come up with a lot of them. An incorrect one would be segment DA. That's actually parallel to segment EH. But you could say segment DB would be skew to segment EH. So skew being that they were not on the same plane. And a plane parallel to plane ABG, ABG being the bottom of the box, the top of the box will be parallel to it. When you name a plane, you will use 3 points, 3 non-collinear points. So I will call it DCF, plane DCF. You could call it plane EDC just as easily. Alright, and that wraps up example 1. Okay, we're going to classify these relationships of these angles that they're giving us. These lines are not parallel, so they don't have the special relationships that they do whenever the lines happen to be parallel. We don't have any parallel lines here, but we do have these kind of angle relationships. So if I'm looking at angles 2 and 6, 2 being right here, 6 being over here, they are related on transversal C with lines A and B. But we do have them lying along transversal C. First of all, they are not interior angles. The interior angles would be 3, 8, 2, and 5. So they are not that. They are, however, corresponding angles. At the intersection of the transversal and line A, 2 is to the bottom right. And over here, 6 is in the corresponding position between the transversal and line B. 6 is to the bottom and to the right. So bottom right, these are corresponding angles. Now we'll move on to part B, angles 1 and 7. Angles 1, 4, 7, and 6 are exterior angles. So 1 and 7 are at least exterior angles. And here's the deal. Because they are on different sides of the transversal C, they are alternate exterior angles. So I'll write that in right there. And now moving on to example C, 3 and 8. 3 and 8 are in the group of interior angles between the 2 lines that are getting cut by a transversal. Now, are they on different sides of the transversal or on the same side? They are on the same side, in fact, and that makes them consecutive interior angles. I also see this written as same side interior angles, depending on what textbook is used. Our textbook, though, uses consecutive interior angles instead of same side interior angles. I would not count that incorrect if you gave me same side. Classify the relationship of angles 3 and 5. So again, we're dealing with interior angles because they're between lines A and B. They are on different sides of the transversal line C, though. So that makes them alternate interior angles. And that wraps up example 2. All right, so we're to identify the transversal connecting angle 1 and angle 2. So the transversal will always be the line that both of the angles have in common. So angle 1 here involves line V and line X is the intersection for angle 1. For angle 2, it's line S and line V. Now, a common side for both of those angles was line V. That is, in fact, the transversal for angles 1 and 2. So I'm going to say that line V is the transversal. When you're naming a line, it's a lowercase letter and it's italicized. All right. Now we're to classify the relationship between the pair of angles. With these two angles at the intersection point, they are in the same location, top left, top left. So because they are corresponding in their location, these are called corresponding angles. That wraps up example 3. That's all we were supposed to do. All right, here comes the fun stuff. When the lines that are being cut by the transversal are parallel, you're going to have what's referred to as special angle relationships here. That the corresponding angles will be congruent. Angles 1 and 3, top left, top left. Angles 2 and 4, 8 and 6, 7 and 5. All those are congruent angles. And also there's even more congruency when you consider that 1 and 7 would be congruent because of vertical angles. So you can see the red angles that they've shown to all be congruent and the blue angles that they've shown to all be congruent. This is by the corresponding angles postulate that the corresponding angles are congruent. Now, with that being a postulate, we don't have to prove that. We accept this to be true. The rest of them are theorems. So we have the alternate interior angles theorem. That is that with alternate interior angles, example 1, angle 1 and angle 3, they are congruent. When you have consecutive interior angles, this is kind of the odd one. Angle 1 and angle 2, they are supplementary, not congruent. It's the oddball. Alternate exterior angles theorem, 5 and 7 perhaps, they are congruent. So these are our special angle relationships only applying to when the lines are parallel. Up to this point in our examples, none of those lines have been parallel. But if you'll take a moment to note which ones are congruent and which one is supplementary. There is also same side exterior angles in other textbooks. Our textbook doesn't get into them because by the time you know this other stuff, you'll be able to fill in the blanks for the same side exterior angles, but they are supplementary. Okay, I'm just going to kind of ride onto the diagram here compared to what I did in class, but angle 110 is 120 degrees, it says. It says find the other measures and state the relationship to angle 10. So while I'm doing this, I'm just going to be stating that verbally what the relationship is. I would go ahead and state that angle 13 is 120 degrees. And what I just used to angle 10 is vertical angles. I would state that angle 11 is 60 degrees. What I just used is a linear pair. This is supplements theorem. Angle 12 would also be 60 degrees for the same reason, supplements theorem. Okay, those are the ones that we would have been able to do before today. Now I'm actually going to go get this set of angles using their relationship to angle 10. So let's go ahead and get going. First one I'm going to use is corresponding angles. That angle 14 must be 120 degrees. That's by the corresponding angles postulate. I'm also going to say that angle 15 is 60 degrees. Now, what's its relationship to angle 10? It doesn't have a direct relationship to angle 10. So what I would say there is supplements theorem and alternate interior angles between 12 and 15. All right, let's go ahead and go back to it. Angle 10, I'm going to use it to find angle 17 as 120 degrees. That does have a relationship. Angle 10 and angle 17 are alternate exterior angles. And wrapping up with angle 16, it's going to be 60 degrees. Not a direct relationship. Some textbooks would call that same side exterior angles. So if you want to use that here, that's fine. They are always going to be supplementary with parallel lines. And that wraps up example 4. All right, so going to go ahead and justify each step here. So I'm not really expecting a formalized proof here, but I am expecting to see every step justified. If you want to set it up as a 2-column proof, great, go right ahead. I'm going to go ahead and state what the relationship of angle 4 and angle 8 are, and that is that these are going to be supplementary angles. They are on the transversal end, and they are on the same side of the transversal, and they are exterior angles. This is one of those that's not mentioned by our textbook, but there is a relationship there that they are supplementary. So I'm going to say the measure of angle 4 plus the measure of angle 8 equals 180 degrees. And I'm going to state that the justification of that is, I'm just going to call that same side exterior angles. Or you could call it consecutive exterior angles. Either way is fine by me. Now we're going to go ahead and move forward with the proof. I'm actually going to go ahead and drop in what was given to me. I didn't write down what was given to me, but that's fine for how informal this is. 4 times y minus 25 plus 4y equals 180. I just use substitution property. And now I'm going to distribute. Hopefully you're on board with me there. So I distributed the 4 there. And that was distributive property. And now I'm going to combine like terms. So 8y minus 100 equals 180. Combine like terms. And add. So 8y is equal to 280. That was addition property. And division property will get me to where y equals 35. And that was division property. One technicality that I kind of made a boo-boo on that I'm going to go back and get right now. This was same side exterior angles theorem. Okay? This was something that could have been proven, and really I should have. So if you're in class, what we'll do is we'll actually do one of those proofs to where we actually prove that relationship. And all those proofs are based off the same thing. They're all based off of corresponding angles postulate. All right, that wraps up our first day of the new unit. Let me know what questions y'all got. Thank you.